Okay, is this is the blank notes, so here's the filled in notes. Whoa, don't look at that. You got some heck coming at you here. Okay, so I did a grouping. You know what? I didn't even do a GCF on this. You don't really need to when you're just getting the zeros. You guys all agree? Plus or minus one and then negative 5/2. Kind of skip the second step of factoring out the 2x squared. That's supposed to say x squared. Let me get that. It's on a video here. No, wrong. Wait. Actually, I think I wrote this one wrong. So this is just an x. Yeah, I don't know why I have a squared on that one. Sorry, that's wrong. All right, so take out a 2x squared. But it doesn't really matter if you take out a 2 and divide it out. You're just solving. So add 2, divide by 2, then square root. You still get plus minus 1. And then remember this. This is going to help us solve inequalities very soon. Maybe it's the next house. I haven't looked ahead. I kind of know what I'm doing. I look at our stuff third hour, but definitely solving inequalities, knowing where that graph goes. And then the second one, take out an x, and then again grouping. And then I knew that this would be x minus 2x plus 2, so I have 2 and negative 2. And then 0. Some people mess this up. That 0, 0 is a 0, 0, 0, 0. And then negative 1/2, which is kind of close to that 0. And then those are all just normal, so it's a typical x to the fourth ending up and up. Everyone good so far? Okay, and then the last one, someone asked me, where is root 7 about? Well, come on, think about it. What's root 9? What's the square root of 9, everyone? What's the square root of 4? So the square root of 7 is between 2 and 3. Probably closer to 3 because 7 is closer to 9. Right? So you do a guesstimate between 2 and negative 2 there. I'm sorry, between 2 and 3 and negative 2 and negative. Then 0. And then 0 is a double 0. So we got that bouncer. So I should say mult 2 on this. Mult 2. And then that's why, hey, let's add to the notes here knowledge of the students. Now, why we're making a sketch, zeros turn into x-intercepts, and then they'll lead to things that we're able to do with solving inequalities is definitely the connection there. You might remember that from last year. I think we had inequalities as well there. So we did those. Everyone was good. Now, let's look at the problem with this and where we're moving into the future, which is now. The future is now. Look at this cubic. That's the word I'm trying to get. And then try to factor by grouping. And just imagine what the problem is here. So I could take out a negative and a negative x squared, and I'm left with 2x plus 3. Hopefully I'm doing that right. Me just good FOILers, good factors. I plug it back in or distribute it back in. It does end up being those two terms back. And then here, I got nothing. I can't even take out a common factor other than 1. And all I'm trying to make the point of is this is when grouping does not work, when those parentheses are not equal. And I had someone say a great comment as I was trying to continue the notes. They kind of interrupted me and said, well, wait a minute. Can I switch these two and then try to group? And yeah, actually that happens sometimes. I could switch the 8x with the 2x cubed negative and then the negative 3x squared, but it still wouldn't work. If you can kind of think of the future, if you GCF'd each of those, you still would not get the same set of parentheses. So this does not factor. Well, then what do? How do I find zeros? And that's what all today is about. One thing we'll do is we'll be cool. We'll say, hey, by the way, one of the factors is x minus 1. So what you can do with that is actually prove it. And you actually have to. But I can do it synthetically. Hey, what number goes in that blank though? What number goes there? 3, 2, 1, go. 1. And then unless we're a liar, we're not. Unless we made a mistake, that's possible. You better get what right here? What number should be right there when you're done? 0. Okay, so you either made a mistake or we made a mistake. It's more likely you, but no, we're not perfect. So it could have been us. Negative 2, negative 5. Negative 5, 3, and there you go. 1 times 3 is 3. 3 plus negative 3 is 0. And then, if you remember from last year, the beauty of synthetic division, you have, what's this called? It starts with a D. It's a what? It's a depressed polynomial. It's been knocked down a notch, much like Mr. Samuelus. I joked 2 years in a row. I've been knocked down a few degrees. Uh, you know what I do on this too? I'm kind of real lazy. Equal 0, right? Huh? Isn't that kind of like, I don't know. It's not true. I just like not having to rewrite stuff. And I cannot stand factoring with a leading coefficient that's negative. So I multiply both sides by a negative and then factor this. Okay, so you deal with the depressed polynomial now that you're squared, and this does work. Okay, and I almost made a mistake. I almost thought it was 1 and 6 or 2 and 3. Is it 2 and 3? 3 times 2 is 6, and then 2 times 2 is 4. I think it is 6. No. Why am I having troubles? Oh, it has to be 2 here and 3 here, right? 4 and 7. No. What's going on? Is it the other way around? Is it 6 and 1? Oh no, it's 1 and 3. What am I doing? Oh my gosh, I'm a buffoon. I can't believe this is it. So it's 1 and 3. 6 is okay, so it's 1 and 3. I don't know why I changed to red. Okay, so this is 6x and 1x, which is a difference of 5x. 6x has to be the larger. So that's the mine. I don't know why I had 6 in my head. I did a little MA thing in my head. That's why I had 6 in there and was doing a trick way of factoring, and it's not good. All right, so sketching this graph, we got 1 as our original 0 because they gave it to us. And then 1/2, that's really close, and -3. 1, 2, 3, negative. And then yet again, this is oh no, this is a negative x cubed. So this goes down. I almost made another mistake. So factoring, I just had the wrong numbers in my head, goofing around there. Somewhat embarrassing, but nobody's perfect, believe me. Okay, now here's where we're going to investigate, except there's something you're going to have to listen to me on. You can synthetically divide by this 2x plus 5. I just want to show you something though. So at first we're going to long division, and this is the one. This is the example where you're going to find out how synthetic division has a little bit of a conundrum when the number in front of x is not 1. Okay? And then you're just going to have to accept what I said there. Oh, and by the way, long division, we actually put the, I was in between both. I'm just messing up a whole bunch here today. And it's all pluses. Okay, so long division. I'm going to do that first and then show you synthetic, and then we're just not going to sketch the graph. We get the sketching the graph part. Okay, so what do I multiply 2x by to get 2x cubed? Come on, tell me. 3, 2, 1, go. X squared. So that means I probably have 2 more steps after this. So this is 2x cubed. Let's go fast. And then 5x squared. And then you subtract. And we're going to subtract in green to show that stick out, because that's the biggest, most important, and most missed step and why people make mistakes. Long division is not hard. It just takes care and takes steps. Some students aren't willing to do that, are not willing to do that. 6x, those are the ones that fail. 12x squared, and then 6 times 5 is 30x. Fail. Fail. You're gone. And then 2x. Oh, then look at that. 2x plus 5, and that's what I have up there. So it is plus 1. You get 2x plus 5, and I don't feel like changing colors. Subtract, subtract, 0 is the remainder. So that is true, it is a 0. Okay, I don't know if I did this or not. I don't think in the other hour I did. I don't think I found the remaining zeros. I forgot to do that. Okay, so I will. No, maybe I did. Okay, but here we go. What happens if I synthetically divided? What would the answer look like? What's wrong with this 2x plus 5? First of all, what number goes in the blank? You set this equal to 0 and get the 0. So what number goes in the blank? -5/2. Okay, so I'm going to show you. This is going to be the example. Now, you don't have to do this. You can always do long division and be fine. If you want to remember this, though, you could do synthetic division, but there's a wrinkle. And it actually happens right away. What's the first step that we do? What do we do with the 2? Bring it down. We already got a problem. What's that number in front of x squared? What's that number in front of x squared? 1. What's that number? But let's keep going. 2 times negative 5 halves is negative 5. Negative 5 plus 17 is 12. What's wrong with that number compared to that number? What's the relationship between the two? 12 is doubled. Huh? You see the 2x plus 5 there? All right, but then there's going to be a problem with this. 2 goes into 12, 6. 6 times negative 5 is negative 30. 2 doubled. Okay, that held true all the way through. Here's where I can't show you what happens with the remainder. The remainder is 0. You have to trust me. The remainder is always spot on. All right, it's only the coefficients of the polynomial that are doubled. If that was a 3x plus 5, they'd be tripled. You got it? Or another way of looking at this, the way synthetic division reads this is you factored by x squared minus 5 halves. That's how that reads when you put negative 5 halves in here. That's why you have this polynomial, 2x squared plus 12x plus 2. If you simply borrowed a 2 and threw it over into this one, this would turn into 2x minus 5, x squared plus x, plus 6x plus 1, and now you see the answer that you see long division-wise. Got it? So that's the problem with synthetic division when the leading coefficient is not 1. The coefficients divide by that, not 1 number. The remainder is correct, though. That's what's strange, and we didn't get to see that because the remainder was 0. All right, but anyway, what's the remaining zeros? Is this factorable? Does anything multiply the 1 and add the 6? Anyone? The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And we're not going to sketch this graph. We got enough work going on here. We already did that analysis of what happens when we synthetically divide. And that's 32. What's 32? A number. What's 32? What times what? What's 32? What times what? 16 times what? What's the square root of 16? 4. Negative 6 plus or minus 4 root 2 over 2, which is negative 6 plus or minus, wrong. Negative 3 plus or minus 2 root 2. Divide everything by 2, including the 4. All right, and then that could turn into a decimal. That's real, and it does say find all the real zeros. All right, okay. Now, so hey, look at these two though, and I forgot to show you also on this one. This is not factorable by grouping. So when it's not factorable by grouping, we're in trouble. How am I going to start this? Well, these two examples, we gave you one of the answers, all right, and you got lucky, and I could see that happening on a test maybe. But then we could also do this. Hey, we'll give you nothing because we're jerks. And then you have polynomials that are not factorable by grouping. So now you're going to have to do what's called the rational root theorem. Remember the P over Q list? You guys remember this from last year? I'm not going over this real fast, or I am going over it real fast. But P is the factors of the constant term. Q is the factors of the leading coefficient. So weird how polynomials work that the only possible rational zeros come from this possibility of a list. So here I'm going to do it and highlight this. Maybe you grab your own. And I know that's negative 5, but I'll take care of that in a minute. The factors of 5 are 1 and 5. And then Q comes from the factors of the leading coefficient, which in this case is just 1, which makes our life easy. So here's what this says. By the way, it's plus minus these possibilities. Plus minus these possibilities. And it's plus minus 1 over 1 and 5 over 1. Okay, so I'll put plus minuses on both of it. So here's what happened. And I'll tell you what had to happen in the kids and students of 2009, 2008, when they had to do their homework with stone and tablet, and whatever. It's like rough times. I don't know how those kids started. They didn't even have ChapSnat. How did they live without their phones in their faces, glued to their face, walking down the hall? It's unbelievable. So those kids are all pretty functional today. I mean that. All right, but anyway, back in the day, they had to then trial and error and find out which ones were zeros, and we're going to go through that today. But realize what just happened. You just went from an infinite amount of possibilities: 1, -1, 2, -2, 3, -3, 4, -4, 5, -5, 6, -6, to just 4 possibilities. All right, and that's what this is. These are the only 4 rational zeros that are possible. And actually circle this word or square it. This is not the actual zeros, but they're the only ones that could possibly work. And that's what those kids had to do back in the day. They had to trial and error and find out which ones worked. And we're going to go through, like, we're going to pretend we're in 2008 again. Boy, back in the good old days. Miss those times. We didn't have viruses back then. We were all fine. Actually, it's not true. There was what was it? Swine flu. In the early 2000s, middle 2000s, we had a swine flu thing. That was the first time masks were. So we did have something like that. This is just plus minus 1 and then plus minus 1/2. So we could have fractional things. All right. Then the last one's kind of rough. And then wait till you see what we do with this on the previous or the next page. This is a big P over Q list because 12 is big. Now watch how I write my list. 1 and 12, I kind of bookend them. Who goes with who? 2 and what? 6, so I bookend them. And then 3 and 4, and then I know I'm done because I met to the middle. 5, 6, okay, I already covered everything then. And then 2 is 1 and 2. And I don't put the plus minuses here. I put it at the end. So plus minus, there's going to be a lot of numbers in this list. So I do this. I don't know if this is correct math syntax, but I'm just telling myself it's plus minus all these numbers I'm going to write in the list. I don't want to write plus minus 12 times. So I do the whole numbers first: plus minus, plus minus, plus minus, plus minus, plus minus, plus minus, all of those. And then I do all the numbers over 2. Before I write them, 1/2, good. Hey, what's 2 over 2? What's 2 over 2, everyone? 3 over 2. What's 4 over 2? What's 6 over 2? What's 12 over 2? Don't write them twice. So I just have 1/2 as unique and 3/2 as unique. So that is not a great list, but it's better than infinity. 1, 2, 3, 4, 5, 6, 7, 8. 16 possible numbers that could only be. But you got to understand there's only 5 real zeros. These are just potential possible. It's the way the polynomials work and the way numbers work. It's kind of a wild idea. So here's what the students back in the day had to do. If this is on the no calculator part of the exam, the first thing you're going to try is grouping. Plus negative, and then you're going to see it's an epic fail. Because when I take 2x squared out, I have 2x minus 5. When I take out a -3, or -4, sorry, then that would be x minus 3. Grouping does not work on this. And then I don't care if you switch the 4 and the 5, 4x and the 5x squared. Doesn't work. So now you're stuck. 2008. You have to do, isn't this the same P over Q list as the last one, right? So let's cheat. It's not the same polynomial, but it was the factors of 12. 1, 2, 3, 4, 6, 12. And then 1/2 and 3/2, because it's still the same constant and same leading coefficient. And then the students back in 2009, this is why I hope you watched my video. I showed you this synthetic division where you can try a couple numbers and only have to write the polynomial once. How many people watched my video yesterday? Raise your hand. That's what I did on that first one of the day. Just if you didn't, just watch. Because here's what I'm going to do. I'm going to take this list now and try these as I go. So I'm going to try 1. Smartest thing, don't try the fraction first. Bring down the 2. What's 1 times 2? 2 plus -5 is what? -3. Can you see that this is already not going to work? What do I need at the end? What do I need right here? What do I need? 0. Can you see how this is not going to work? When you can see it's not going to work, cross it off. 1 times -3 is -3. -3 plus I'm done. My brain, I know this is not going to be 0 at the end. I'm not going to get a 0. This is not going to be -12 on the next part. Then I move on to -1. 2. Negative 2 and negative 5 is negative 7. Oh, negative. I could stop now. I already know it. But negative 1 times negative 7 is 7. 7 plus negative 4 is 3. Is this going to be 0 at the end? No. Cross it off. Careful crossing it off too early. You may kill a right answer. 2. 2 times 2 is 4. 4 plus negative 5 is negative 1. 2 times, is anyone getting excited? 2 times negative 1 is negative 2. Negative 2 plus negative, I'm excited. 2 times negative 6 is negative 12. Negative 12 is 0. Boom shakalaka. Students of 2008 had to go through a trial and error until they got 1, 0. Here's why. What is this called now? Anyone? Anyone? Depressed polynomial. It's been knocked down a notch. That's the constant, and then we could say equals. This is not technically true, but I just like being lazy and not have to rewrite it. Because now what I'm going to do is factor that. I'm done. Don't be going to your P over Q list and trying to find more of that work. You're wasting your time. Okay, and then I think this is factorable. Just going to get this over with. This is 2x and 1x for 2x squared. Probably going to have a 2 and a 3. 6, yeah, because it's not 4. 3 times a 2. The middle term is off by 1, so this is 4x and 3x. And I need the bigger one to be negative. So that's how I factor. I keep doing this. Please do factoring this way. Okay, 3 times negative 2 is negative 6. Double check. Okay, so now, what are my zeros? They are, don't forget you had 2 here. Wait a minute. And then I had negative 3 halves, right? But then I had what? What is that 0? 2. What does that mean about 2? 2 as what? Mult. Anyone? Mult 2. And then negative 3 halves. And if they did ask you to do a graph, that'd be bouncing. All right, but they don't ask about graphs, and I don't want to overdo it. So it is a multiplicity 2, 2, 2, 2, 2, 2, 2. Oh, okay, I'll show you this. It's actually bad on this one, though. No, you know what? I'm not. I'll show you. No. Yeah, should I? Yeah, let's do it. Hey, get out your graphing calculator. This is why the P over Q list became obsolete. The graphing calculator kind of took over. So I'm going to show you, and I already have it, but go ahead and type example 8 in your Y1 screen. All right, I already got it done. Boink, boink. Y equals. My fat head's in the way. I guess I can't move that from here. Okay, so I went Y equals. Where's this thing? Giving them time to do this anyway. And then I went ahead and typed it. X to the 4th minus x cubed minus 6x squared plus 4x. And then I can go ahead and zoom in on this. Okay, that's fine. Go in this corner this time. Nope, down here maybe. Probably could just get rid of me. I do like knowing that we're live in class. Okay, now watch this. Now, if you're on the calculator part of the test, and notice this is an x to the 4, you have to know that I have to double depress this, by the way. I got to depress this to an x squared. I'm sorry, x4 to x cubed, then x cubed to an x squared. But if this is on the graphing calculator part of the test, put it in y equals and then look. Okay, and I zoom standard. I actually got all the answers. But you got to prove it. And pretend this didn't cross. So pretend this is off the scale, and these are the only 2 that you see. What does that look like as an x-intercept? What number does that look like? What number does that look like? Negative what? Fifth hour doesn't say a word. Hey guys, this is how you do a number line. You go, here's 1, 2. What number is that? Negative 2. There are human beings in here, believe it or not. And then what number is this? When you go 1 left, class, what number is that, everybody? Negative 1. We got them. Teenagers just look at you. I don't have to. I have rights. You can't ask me questions. Anyway, so we're going to prove it. We're going to prove it. And by the way, you have to prove it. Because let's pretend, if you were listening back to the graphing calculator, that these are like up here, which means imaginary, or the zeros look like they're decimals, and I don't know what they are in exact format. Water bottle over there. All right, shuffling their bag in the middle of the notes. 1, -2, -3. -2 times -3 is 6. 6 plus -6 is 0. Good, 0, good. -8. This should have happened from what I saw on the graphing calculator. Now, guess what? I'm going to change colors because this is a depressed polynomial, but it's a cubic. And that cubic would not be factorable by grouping. You're missing a term anyway. So guess what you're going to do? You're going to synthetically divide this depressed polynomial by the next zero that you saw that should have been a 0. So this is how you can use the graphing calculator to kind of eliminate the need for a P over Q list. This is why the P over Q list, with my regulars, I don't even know if we cover it, because I think we just say we're going to do this on the graphing calculator part. Bring down to 1. -1 and -3 is -4. -1 and -4 is -4. 4. My bad, dogs. And then -4 plus 4 is 0. Okay, and then you already saw the other zeros anyway. Fine, it was a double 0. That's because we've now depressed this twice to an x squared, and then this factors to be x minus 2 times x minus 2. So my zeros that I saw with the graphing calculator but also proved are these 3, but one with multiplicity 2. Okay? Now we're going to play the game that we don't have a graphing calculator. We're going to play the game that the math teachers are jerks. And they put this 4x cubed one. I think it's this one. Yeah, I think this is the one where, or is it the last one? Maybe I didn't. You know what? No, forget that. I didn't even do that. You know why? I think this one's factorable by grouping, isn't it? Right? Yes? I take out a -4 out of the second batch and I get 4x plus 1, right? Yeah. So it's good. So I didn't even do that when I did this one. Okay, graphing calculator taken away. Wow, I hate this class. Error. All right, so I got to do this. I got to do the 1 and 5 thing, and then I got to do the 1 and 2 thing, right? So factors of 5 over factors of 2. And then the list is plus or minus, let's be lazy, 1, 5, 1/2, 5/2. Okay, and we could very well do this on your test. No calculator. So again, here we go. Yoink, yoink. 2, -3, -3, -5. Probably going to start with 1. Usually we're nice. 2, 1 times 2 is 2. 2 plus -3 is -1. 1 times -1 is -1. -1 and -3 is no, actually not even close at all. 1 times -4 is not 5. I would need that to be 5. So let's move on. -1, right? We okay? We doing this? Yes, get it? Don't go all the way if you don't have to. 2, 1, -1 times 2 is -2. -2 and -3 is -5. 5 plus -3 is 2. Can I crush this? This is not going to work. You're not going to get a 0 at the end. 5. Oh, this is what the kids of 2008. I couldn't even live in that day. They didn't even have ChapsNet. They didn't have face space in my book. 5 times 2 is 10. 10 and -3 is 7. Oh, come on. 5 times 7, 35. Isn't this getting nuts? Like, this is way too large. There's no way you're going to get a 0 out of that. Okay, so then -5. Oh my gosh, this is the worst. They had to do this. Okay, 2, -10, and at -13. Isn't -13 times -5 65? Are you ever going to get a 0 out of that at the end? Right? Holy cow. This is the worst. Let's try 1/2. Got to be this fraction. What's half of 2? 1. 1 plus -3 is -2. Half of -2 is -1. -3. Is this going to work? Is this going to work? No. I hate math. -1/2. Okay, now move over right here. Okay. No way. All right, so 2. Negative half of 2 is -1. -1 and -3 is -4. Negative half of -2 is 2. 2 plus the, oh my gosh. Are any of these going to work? Did this literally go to the end? Is anyone ahead of me? Is anyone ahead of me? Did anyone jump ahead? Are you ahead? No? Okay, now on a test, I'll doubt we'll go this bad. Probably be one of the earlier ones that actually were, like our first example. But 2 goes into 5 halves 5. 5 plus -3 is 2. 5 halves times 2 is 5. 5 plus -3 is 2. Hey-o! We finally got a success. 5 halves times 2 is 5. 5 plus -5. Rejoice in the streets. Thank the maker if there is one in a public school. All right, now, remember what I said about synthetically dividing by this. Technically, this reads like this. This is x minus 5 halves as a factor. Don't write this down. Don't write this down. Don't write this down. And then this is 2x plus 2, which is equivalent to this being 2x minus 5, and this being 1x squared plus 1x plus 1. Got it? That's the whole conundrum about synthetically dividing by 2x minus 5, which is not what happened here. So I don't care about that. I just need to take this depressed polynomial now and solve it. And obviously, the first thing I would do is divide by 2. And then it says real zeros, but we're better than that. How do I get these zeros when this is not factorable? The opposite of b plus or minus the square root of b squared minus 4ac, there's that I number, all over 2a. So we're actually going against the against what the directions say. My zeros are 5 halves and -1 plus or minus. This is the square root of -3. So that's I root 3 all over 2. You should not have answered that because it says in the directions the equation's in the real number system, right? That's imaginary. But we know how to do that. So I just thought I'd reference it. Okay, now I'm done. Now I'll leave you alone.